Hi, and good day to each and everyone. Well, I'm good in here, and I just hope that your everything's also okay at your end. This is our 11th week into the course, and guys, girls, we have 3 more weeks to go. So heads up and cheers. Our topic for today is an overview of designing the supply chain network, which will require us to dive deeper into the logistical drivers that we've covered in our previous lectures, that is about facilities, remember, which, as we've learned, deals with either factories and or warehouses. In this lecture, we'll focus in the use of established and proven linear programming models in deciding the most appropriate supply chain network given the particular cost parameters and constraints, and solve it using our knowledge of linear programming and its related transportation, transshipment, and assignment problems, which we've learned in our prerequisite 1TT course. Let's recall that linear programming, or LP for short, also called linear optimization, is a method of achieving the best outcome, such as maximum profit or lowest cost, etc., utilizing a mathematical model whose requirements are represented by linear equations. More specifically, LP and its variants, there are quite many, is a technique for the optimization of a linear objective function subject to linear equality and inequality constraint. Remember the theory of constraint that we discussed before? It utilizes a programming algorithm that finds a point within the feasible region as may be defined by the stipulated constraints, where this objective function has the smallest or largest value if such a point exists. It seeks that goal in an intelligent, iterative manner, of course, using a computer as a practical prerogative. Anyway, in this course, we won't be starting from scratch, as there are already established LP models that we can use and work on. We just have to refresh our knowledge of linear programming, more particularly the transportation and transshipment problem solutions, and recall how to use the Excel solver. Okay, so we better get down to it. Network design in the supply chain. In this lecture, okay, we will focus on the fundamental questions of facility location, capacity allocation, and market allocation when designing a supply chain network. We will identify and discuss the various factors that influence the facility location, capacity, and market allocation. We then establish a framework and discuss various solutions, methodologies for network design decisions in a supply chain. We are now in our ninth special topic, and just like the rest that we have taken up earlier, this special topic should supplement the 10 strategic areas that we have covered in our introductory OM courses. All of them are supposed to be used in arriving at the most appropriate strategy or strategy mix when managing any operation function. At the end of this lecture, you are supposed to understand the role of the network design in a supply chain, identify factors influencing supply chain network design decisions, develop a framework for making network design decisions, use optimization for facility location and capacity allocation network. More specifically, we will focus on the linear programming capacitated facility location approach. These are the topics that we will cover in this lecture. Let's start with the role of network design in the supply chain. Supply chain network design decisions are classified into four. First, facility role. What role should each facility play? What processes are performed at its facility? Maybe a warehouse or a factory. Facility location. Where should facilities be located? In China, in Mindanao, or some other parts of the world? Capacity allocation. How much capacity to be used at each of the facility that you will have installed? Market and supply allocation. What markets? Which supply sources? These are the things that we're going to tackle in this lecture. Then of course, lastly, just like in any other decision, we have to be dynamic and proactive. No, we have to revisit the design decisions after some changes in the market. In fact, not only change, but you have to monitor closely and be proactive. Factors influencing network design decision. In this section, we examine a wide variety of factors that influence network design decisions in supply chain. And these factors can be divided into the following. First, strategic factors. Okay. What are strategic factors? A firm's competitive strategy has a significant impact on network design decisions within the supply chain. Normally, the firms that focus on cost leadership, that is, want to be cheaper, tend to find the lowest cost location for their manufacturing facilities, even if that means locating far from the market they serve. On the other hand, and in contrast, firms that focus on responsiveness, remember that efficient and responsiveness continuum, tend to locate facilities closer to the market and may select a high-cost location if this choice allows the firm to react quickly to changing market needs. Global supply chain networks can best support their strategic objectives with facilities in different countries playing different roles. No? A good example is the one that in your readings, I think I just mentioned it about Zara. Zara is one of the popular consumer outlets. They have one in Mega Mall. Okay? Zara maintains production facilities in Europe and in Asia. However, they assign different rules to these facilities. No? The Asia facilities focus on low cost and primarily produce standardized low-value products that sell in large amounts, consumer goods. However, the European facilities focus on being responsive because most of their market is in Europe. So they are based in Europe and being responsive to whatever the needs of the marketplace. And primarily produce cutting-edge design whose demand is unpredictable. In fact, this is a good combination as far as Zara is concerned because they have a very efficient plant in Asia and they have responsive plant in Europe. Technological factors. Characteristics of available production technologies have a significant impact on network design decision. If production technology displays significant economies of scale, a few high capacity locations are most effective. Well, it's a general observation that high capacity plants are more efficient than many low capacity plants. This is the case. Well, an example here in our country is the cement industry. Cement industry are, normally operates in big, large capacity because they find efficiency there. And well, cement in terms of value is low compared to the transportation cost involved. That's why in the Philippines, I think we have only 4 or 5 cement plants. In the US or in advanced countries, I think the computer chips industry, the one that making chips for computers and other gadgets, normally operates or invests in large plant to be more efficient. That's one of the things that, in contrast, if facilities have lower fixed costs, many local facilities are preferred because this helps lower transportation costs. An example in your book, in your reference, in the case of Coca-Cola, their strategy, since their plants don't have a very high fixed cost, the strategy is to maintain so many plants around the world. And I think Coke, the value of a Coke, pretty expensive compared to the transportation cost of moving this. So that's why they have to be closer to their market. The third factor is the macroeconomic factors. This include taxes, tariffs, exchange rate, shipping costs that are normally not internal to the firm. In fact, they affect everybody. As global trade has increased, macroeconomic factors have had significant influence in the success or failure of supply chain. Thus, it is imperative that firms take these factors into account when making network design decisions. The fourth factor is political factors. Well, political stability is one factor to be considered, no, when deciding on location choice. Normally, companies prefer to locate facilities in a politically stable country where the roles of commerce and ownership are well defined. In fact, I may add here the rule of law, very important in business. While political risk is hard to quantify, there are some indices that can be used. For example, the Global Political Risk Index, GPRI. We have also what? The CPI, or not the usual consumer price. CPI here means what? Corruption Perception Index. And I think there is another one that I've encountered, the competitive index. These are maintained by different agencies and are updated on a yearly basis. Infrastructure factors. No? The availability of good infrastructure is an important prerequisite when locating a facility in a given country or area. Well, infrastructure, you're talking about what? Internet, electrical power, water supply, roads, airports. Poor infrastructure adds to the cost of doing business from a given location. Okay, so take note of that. Key infrastructure elements to be considered during network design include availability of site and labor, proximity to transportation terminals, rail service, proximity to airports and seaport, utilities, including internet and Wi-Fi. Very important. The next factor is competitive factors. Well, competitive factors are very important when designing supply chain network, because actually it involves two approaches. Some school of thought say that if there is a positive externalities between companies or firms, what I mean is that when co-location, they locate on similar areas, will benefit all of them, then probably that is one approach. If you believe that by co-locating or locating in the same area, it will benefit everybody, then do it. In fact, that's probably the reason why in malls, stores are situated in the same area. They have a separate floor, all the gadgets there, another floor for all the computers. That is the reason behind positive externalities benefiting all the stakeholders. However, if there is a need, when there are no positive externalities, then first we decide to locate with the intention of splitting the market. And splitting the market, there are different theories here, but basically involves what? Normally, the firm that are well positioned or well located will get the bulk of the market. Okay. And normally, if you are nearer the market, you'll get the bulk. On the other hand, if you are far or the conditions of your location are not favorable to the customer, then probably you will get the letter. In fact, in my handout, there is a formula there, but again, it's a complex topic. But the basic reason here is that proper location will track uh, the market, whether it's through short distance nearer or favorable infrastructure that will attract market. That's also one thing. Another one is customer response time and local presence. Of course, how fast you are able to respond, and preferably if you are present in the locality, then you will get substantial market there. Okay, let's move on. Logistic and facility cost. That's another factor. It is incurred within a supply chain. It changes as the number of facilities, their location, and capacity allocation change. So whether you decide to have so many facilities, it will affect your logistic and facility cost. Company must consider inventory, transportation, and facility costs when designing the supply chain. Correct. Inventory and facility costs increase as the number of facilities in the supply. Take note, the more facilities you'll have, normally your inventory and facility costs. Transportation, on the other hand, cost decreases as the number of facilities, because there will be shorter distance to travel. Total logistic costs are the sum of the inventory, transportation, and cost. In fact, if you will recall in our discussion about performance driver, this inventory, transportation, and facility were categorized as logistical driver. In short, I think the three other drivers, there were six. No? Information, sourcing, and pricing were called what? Cross-functional drivers. But these three, inventory, transportation, are logistic. And it affects your cost depending on how many facilities there are. It affects the transportation, and it affects also the kind of inventory that you are going to maintain. Okay, so let's now go to coming up with a framework for network design decision. Now, in what I think mentioned earlier, it's always when you are studying something or important thing that you want to always bear in mind, try establishing a framework, because a framework will help you recall, a quick recall of the important things of that field that we're studying. If we're talking about network design, it's important that we have what we call as a framework. The goal when designing a supply chain network is to maximize, remember that, firms' profits while satisfying customer needs in terms of demand and responsiveness. To design an effective network, the manager must consider all the factors described in the previous lectures that we have, and in fact, in the previous slide that I've shown you. Global network design decisions are normally made in 4 phases. And I will illustrate that by way in the following slides. The first phase, you have to define a supply chain strategy. Clear definition of the firm's competitive strategy, which we have discussed in our earlier lecture, talking about strategy fit of the supply chain vis-a-vis the strategy of the firm. Forecasting the likely evolution of global competition. No? So again, just like in a business, you have to look into the future, how it will look like after, say, what? The pandemic, what will business be like? Then identifying constraints on available capital. Again, a basic thing that we have also learned in operation earlier is constraint. There are things that would prevent you from doing more. Here it talks specifically of capital. You want to put up a plant, but you don't have money. What are your constraints? And then determine broad supply strategy. Well, this is a domain of the strategy fit discussion that we have had in our previous lecture. Okay, let me show you this chart. I think we can already discuss the 4 phases here. Phase 1, phase 2, phase 3, of course, phase 4. So what I mentioned, phase 1 talks of what? A clear competitive strategy. Are you going to be more efficiency side or on the more responsiveness side? Internal constraint. So that requires self-assessment, honest assessment. What are the limitations in your company? And of course, the other one is global competition. What will it look like after the pandemic? What kind of business are we going to play? Will there be more outdoor restaurant or maybe more on delivery service? These are the things that you have to also. That's phase one. Now going to phase two, there are things that you have to also consider. Production technologies, manual, computerized. Well, my friend, we are now going into the fourth industrial revolution, where all the technologies available now are merging. There is this concentric merger of technologies from big data to artificial intelligence. The other one is competitive environment. What is the competitive environment in terms of competition from China, from the European countries? Aggregate factors and logistics costs. Well, these are, of course, costs are very important in business. That's why you have to watch out logistics. And when we talk of logistics, remember we will talk of inventory, transportation, facility costs. Tariff and tax incentives. Well, there are government laws that manages this thing for any country. But countries normally have a regional bloc, just like the ASEAN, where they provide a preferential agreement among members. Regional demand, what is the demand? ASEAN, we have is the growth fast, slow, and how does this compare with demand from other non-ASEAN countries? Political in exchange rate and demand rest. These are things you have to consider. In short, practically, you just have to do a lot of research and to come up with how you are going to configure yourself in the region that you are in. Phase three will require you have to know what are the production methods and then, of course, available infrastructures. And lastly, you have to know the factor cost, and logistical cost. That would be inputted in phase four, where you will be normally using a decision model to arrive at your choice. Okay, phase two is what I mentioned earlier. It talks about developing a forecast, of course, determining the economies of scale or scope in operating, whether you produce in large numbers or specific targeted market. Identify demand risk, exchange rate risk, political risk, all the risks, and of course, lastly, your competitor. Phase three, you just have to select a set of desirable potential sites. So in short, you identify where you have some site in Europe, in China, in ASEAN, in the US, okay, already. So this requires a geographical assessment. And lastly, you just have to decide on which location, and normally you just have to use a decision model. And in our case here, we'll be using the capacitated facility location model, which uses the linear programming approach. Models for facility location and capacity allocation. Now, I have here some slides that I have prepared for you, but take note that I also send you a copy of the Excel solver model that I developed for this example that I'm mentioning here. No? So I trust you have gone over them. Presumably, I also assume that you have correctly activated your solver add-in in your Excel software, no? Because we'll be using that in discussing the following example. A manager normally consider many trade-offs between network design. That's why, because of the so many trade-offs that you're going to decide, you just have to seek the help of computerized decision model. That's why I'm recommending here that we use the capacitated facility location model. You can either maximize your overall profitability or minimize cost depending on the available data that you have. And there are, what I said, many trade-offs during your network design. We have to use established and proven decision model to help us tackle, to decide on locations and capacities that you are going to operate, and to assign current demand to facilities and identify transportation routes or lanes. And these are the information that you should have when you use a facility location model in our case. Already location of supply sources and markets. You already instruct your procurement for the supply and your marketing people to really do some scouting on what are the possible location and send out your engineers to really scout on potential facility sites. A demand forecast, this is a marketing domain, of course. Marketing being needed, the customer should be able to crank out a demand forecast. Facility labor and material costs by site. So this is a joint effort by your procurement, your engineering, and your HR. Let them go to various sites that you've identified and try to get as many information, relevant information, okay, that you will feed into your model later on. Transformation cost between each pair, so your logistic expert. But now normally, if you know the distance, normally you can have an estimate of the cost, transportation cost, whether it's by sea, by land, by air, because there are standard actually. For particular commit land distance in kilometers, there are standards. For sea roads, for every nautical mile, there are standards, and for air roads, there are also standards. Inventory cost by site and as a function of quantity, well, you just have to rely on what strategy you're going to, because if you're talking of a more responsive strategy, then you just have to stack up on inventory. And take note that inventory costs money. Sell price of product in different regions. Well, this is a domain of marketing. Then you just have to work closely with marketing on how you are going to sell your product, different outlet that you have. So probably you may wonder, why is it cheaper to buy in Bangkok than in Manila? Well, the regional marketing knows how to play around with prices. They don't have to price it necessarily the same. Taxes and tariffs, well, this is the domain of the government for each country. They have laws. And of course, when there are regional cooperation, they have what? Bilateral trade agreements, and in fact, regional preferential agreement on members. Desired response time and other service factors. These are things that will again be determined by your strategy. The use of network optimization model. In our case, we'll be using, what I said, the capacitated facility decision model. One advanced feature of this model, as compared to the model we've studied in our probably earlier courses in quantitative management, while in our quantity, if I recall, I was teaching quantity for a while, the nearest model that we're using is the transportation and the transshipment model. Unfortunately, in that transportation and the transshipment model, it only considers variable costs. It doesn't include fixed costs. Now, in the model that we are going to use later, we will consider the fixed cost of operating a plant, because, as what I said, realistically, costs should be composed of both fixed and variable. It's important to consider them, the two of them, especially when the fixed cost varies depending on whatever your decision is. And quite frankly, in a supply chain decision, network design, facility and variable cost matters. That's why in the model that I'm going to discuss later, I will be discussing the more practical aspect. Now, there are several slides that I have. I trust that you yourself will recall what you have learned in your earlier courses in statistics and in quantity. But I know people don't really like mathematical symbol like this. But these are the relevant terms that we have to deal with when we use the capacitated facility location model. The objective function is to minimize cost. But of course, as what I said, with proper manipulation, you could also formulate your model to maximize your profit. But in this example that I'm citing here, and for our course, I decided not to go further than the model that I'll be discussing here. Okay, so pay attention and try to focus on understanding the model that I will be discussing. Okay. I'll be making use of the actual Excel worksheet now. after a few slides so that I think it's more clearer that way. Okay. So the objective function is composed of two factors. It is the minimization of your fixed cost. This is a fixed cost actually. And yi here is assigned a binary values. Binary meaning either 1 or 0. If the computer choose y equals 1, that means you allow that particular facility to operate. If it gives a value of 0, then it doesn't allow that facility to operate. And it's a summation of all the factories allowed to operate, product of uh, fixed cost, uh, and of course a binary variable. The second aspect are the variable costs. No? The cost of producing and shipping the product from one plant to a market times the quantity. Okay. So the source here is I and the market is J. So if it's mean Xij from plant I to market J, and it is a double summation. And when you encounter double summation, okay, if you if this is the data that I have shown you earlier, double summation meaning summing horizontally and vertically. That's what we call as, that's is the total, overall total of values horizontally and vertically. Okay? Of course, times the cost. Then, of course, in the constraint, this is the demand constraint that all X summation of all products produced and shipped should satisfy the demand. And here is equals to capacity. All the production should be equal to the capacity that will be allowed to operate. That's what there's Y1 there. No? So the computer will assign a value 1 to Y, to Y, yeah, if it allows a factory to operate, and a 0 if it doesn't allow the factory to operate. All the others are technical condition. X is non-negativity condition, and of course, Y here assign a binary required to assume a value of 0 to 1. So with that, I will now share you my Excel sheet, no, and try to continue my discussion there. Okay. Okay. I have pulled out my Excel sheet. Okay. And by the way, I made I think that was news advisory number 27A, and attached a copy of this Excel sheet. And there was also a video show showing how to activate your Solver account, Solver add-in. Very easy, no? To activate your Solver media, you just click and then more, and then options. Okay. When you arrive at option, you click add-ins. Okay. And you should see the Solver add-in here. Okay. You click on that and then click what? Go. Okay. When you click that, a sub window will appear. In my case, since I have already activated it, it's already checked. But if it's not, then you have to check the Solver add-in here. In my case, I also click the analysis toolbar. Okay. So with that, you can click OK. And when you do that, when you click on the data tab here, the Solver button should appear here, no? Okay, Solver button at the upper right corner under the data tab. If you click that Solver, Solver sub window will appear. Okay, and I trust you're familiar with this already. You recall what you have learned. No? I know I've been teaching quantity for a while, and this is one topic that I normally discuss. If not, there is a help section that you could always bring out. Okay, if you have some question, okay, you could always bring it out. Okay, fine. And then, of course, we know that this is where you have to prescribe your objective cell, whether it's maximization or minimization, and then you set whether it's maximization profit or minimization of cost, and then you specify here what are the cells that you want the computer to change, and then of course your constraint, you have to formulate the different constraint here. And normally you have to choose, in our case, a simplex LP function. And then, when you add constraint here, you have to push add here, and then another window will come out, and then this is where you indicate the equation of your constraint. Okay, either equals, greater than, or integer. If it's binary, then you specify binary. Binary meaning you only allow two values, either 0 or 1. Okay. So again, these are all, we don't have time to discuss it here. I presume, there are a lot of literature. There was a video I attached, and of course there are help things that you could always pull out whenever you have a question. Okay. Okay, so I will close that. In the meantime, let's go to the model that I sent you. Okay, this is a typical formulation. By the way, formulating a linear programming model is both an art and science, meaning no two analysts or two modelers will come up with the same, because there are individual preferences that you consider. But I consider this as one of the classic way of formulating capacitated, facility location linear programming model. Okay. Now, let me just go over the general structure of the model. Okay. The first matrix here is where you provide the data that you will use in the. These are the normal requirement. Of course, the column here specifies the plant origin, where the plant is supposed to be located, the one that will produce, okay, product, and then down here, up here, is the market, possible market. So in this case, it's just so happened that there are 1, 2, 3, 4, 5 regions where specific eyed to, eyed as location for our factories, okay, and then so to be sold to the same 5 regions, okay. So it is a matrix, okay, and of course the beige colored here, this provides you with what? The variable cost of shipping a commodity from North America to North America, it's 81, okay. From North America to South America is 92. From Europe to North America is 102. This is dollars per 1 million units. Yeah, I think that's the cost. Per 1 million units. So this is the cost. Okay. Now the blue range here, okay, is where you specify the details about the facility in terms of its fixed costs. When you operate a facility, you have to specify the fixed costs. And in this particular case, the facility, there were 2 configurations of facility here. No? Either a low capacity and a high capacity with the respective fixed cost. What it means actually, again, this is one way that this modeler have interpreted the problem. He allows the model to generate either a low capacity or a high capacity. In some, they only allow single capacity and whether they allow it to operate or not. But here, there is an additional option of operating either in low or high capacity. Now, this can be interpreted, the way the figure looks like here. It provided a 10 and a 20 here. By ratio, the cost here is what? 10 to 20, that's 1:2. Okay? So I may interpret it as you allow this plant to operate at low capacity by operating only a single shift. Okay. Here probably allow it to operate at 2 shifts. Okay. And that's what it means. The high capacity and low capacity. That's one practical way of interpreting these figures. No? The low capacity is one half the capacity of the high capacity. So probably a 1 to 2 shift. Normally, that's how company operate. No? Uh, one 12-hour shift and two 12-hour shift. Okay? And then they have the corresponding fixed cost. Well, because uh, you operate at higher capacity, the fixed cost is higher in terms of number of people, number of supervisors. It's there. So don't see that. The second matrix is the decision variable. This is where the computer will assign the most appropriate value that will satisfy the objective function. The objective function is somewhere here. Okay, this is the how it is stated here. Okay, it's just as simply okay. Objective cost is the total of all variable costs that will be generated plus all the fixed costs. That's why the sum product, okay, production cost. Okay, okay. So uh, uh, initially, by the way, this is already the result of the solver run that I did. That's why there are already values. But initially, when I started this, all the values here are 0. Okay, okay. And then when I call my solver, okay, when I call my solver, and then starting inputting all the my objective function, okay, and I ask solver to change all this value here. This one, that's actually this range, no? And then of course included all the constraint. No? One of the constraint I inputted here is that I instructed computer to only assign binary values to this green range here. You cannot assign in it, but only 0 or 1. Okay. And B14 to each 14, before this 14. I thought that this is a non-integer, non-negativity constraint. You cannot assume negative value. So the values in this yellow range should be either 0 or greater than 0. Okay. So I cancel this, close this for a while. The yellow here, yeah, optimal value quantities to be shift from factory I to market J. Factory I will be here to market J. So it says here, no, that after solver, it's very quick. When I play solver, automatically it, okay. For example, if I rerun this, okay, run this and then ask solver, assuming that it's already correct, okay, I click solve, automatically, matter of second, less than 1 second, no? It provide. That's how fast, no? Fast the solver algorithm really. Now let's recall that the LP algorithm, no, it is actually an instruction to the machine. In fact, this is an old version of what we now call as AI or machine learning. No? It gives instruction to the computer to seek by trial and error, no, seek those values, and always keeping in mind that the goal is to minimize the objective here. So the computer will make the first trial, second trial, but as opposed to a usual trial and error thing, in this algorithm, it always take a look at the objective. If it generates a trial and then it, you know, increases the value here, then it will go to the other side. It is self-correcting, always ensuring that every trial it generates will give a lesser value here. Okay. In this case, according to solver, after very quick, no, less than 1 second, trial and error, it found a solution. Okay. So I said, okay, I'll keep the solution, and then and it is all the solution is printed here. And what it says is that, okay, given this data, this is what solver said, okay, that you're giving me, and based on the instructions you've given me, I was able to arrive at a solution, okay. The minimum cost will be 23,000 something, okay, 23,000 what? 23,751. Okay, that is the solution. And to accomplish that, okay, we have to produce 12 uh, thousand million, no? Because this is in million, product allocation, 1,000 units. So this is 12,000 units, okay, from South America to be delivered to North America, okay, thereby satisfying that demand of 12 here, the demand of North America. Another one is to also produce from South America 8,000 units to satisfy the need or demand of 8,000 units in South America. And then Asia will have to produce 4,000 units to be shipped to Europe. And then in Africa, it's going to produce 10,000 units to be shipped to Europe so that it will satisfy the total 14,000 requirement of Europe. Asia, on the other hand, okay, it says here, okay, let's produce 16,000 in Asia, okay, and then to satisfy the demand of 60,000 in Asia, and then for Africa, it also produces its own 7,000 to be only shipped to South Africa. Okay. Now, quite interesting here. So it doesn't mean that the closer you are, and this is why I skip the discussion of the other method, no, which was in my slant out, that gravity method, because the gravity method is based on distance. No? But as you can see here, it doesn't mean that if you are near, you are the preferred route. No? Just take a look at North America. Because of other things, and most likely it is the cost involved, no? Probably the variable and the fixed cost. Instead of producing in North America and delivering it to North America, no, the computer, no, it's not economical. You'd rather not operate. Zero. But in the case of Asia, probably because of economics, yeah, you can produce 4 units, Asia, and deliver it to, Asia, here, Asia. You can produce 16 units to satisfy your own demand in Asia. And in fact, even Africa. Yeah, go ahead, Africa, you operate and then satisfy your demand. Okay. How did the computer did it? Is by, again, assigning value to this range here, the green area. Computer, by iteration and by proper algorithm, okay, it was able to decide that, okay, let's operate only the large plant. There are no small plant being allowed to operate. Large capacity plant, but only in 3 areas. In South America, where it assigned a value of 1, meaning it allowed to operate this plant. And then in Asia, okay, it assigned a value of 1 here. So that, and then also Africa, it assigned a value of 1 here, allowing this plant to operate. Okay. That's how intelligent this guy. No? So in short, the usual reason that you operate as close as possible to the market is not always correct. No? Because there are other things to consider, and that is being considered here in our capacitated facility location. Europe, for example, again, Europe was not allowed to operate, no, to supply its own requirement. Europe, by the way, has a total requirement of 14,000 units, but the computer did not allow it to operate. Zero. Okay. Now, another thing that is, you are able to, again, there are formulas in constructing the third matrix actually talk about how you were able to satisfy the demand or whether you are not able to utilize your capacity. So the first excess capacity is just a difference between the capacity of the plants being allowed to operate, okay, and the capacity is stipulated here, all high plant 20. So this minus all the total production, the one in yellow, the total quantities in the yellow, okay, sum of B14 and E14. This one for in North America, the total of that. For South America, the total of that. You deduct from the capacity being allowed. No? The capacity being allowed is for South America is what, 20,000. Okay, and you will notice that there are no excess capacity except in Africa. Okay, Africa, there is an excess capacity. So in short, the capacity is not fully utilized in Africa. Capacity is 20,000. Africa minus 7. What is utilized in Africa is only 17 out of 20. So you can compute the, if I ask you in the exam, what is the utilization of the plant in Africa, then that is 17 divided by 20. It was allowed to operate at high capacity, large capacity, but it has an excess capacity of 3. So if, for example, in the exam, I'll ask you, what is the capacity utilization of the plant in Africa? Okay, it is what? 17, 20 minus 3 divided by 20 times 100. Now, the other figure in this matrix is what we call as the figure on unmet demand. And this is just a difference between the demand here in the first matrix minus that in total of each column product here. The total of this 12 minus the total of this, 8 minus the total of that, 14. And that's, you will notice all the demand were really satisfied. Okay. And then with that, all the constraint satisfied, the computer computed its optimal cost at 23,731. Okay, that includes both the variable cost of production and shipment and the fixed cost required to operate the plant that it allows to operate. By the way, all plants were allowed to operate in large capacity. The rest are not allowed to operate by the computer. Okay, so I will not go further than that. No? I'm giving you this as a guide. This may come up in the quiz or in the final, but you will no longer be required to formulate the problem. Okay, probably I'll just change the name here. Okay, and probably some of the cost items here. Okay, cost items, and ask you, on the premise that you already have installed your own solver. So make sure you have your own solver. I ask you to rerun it again and ask you a question. Okay, what is the minimum cost achieved? What are the excess capacity? What are the unmet demand? What production, what plant are operating? At what capacity, large and low? Things like that. Question, very related, but well, I know formulating the problem is a quantity mission. In our case, I just want you to utilize, especially this one, which is an established and a proven technique already, okay, to realize. Of course, it's another thing. If you want to enhance this project by adding more plants, it will require a lot more knowledge, of course, Excel and Solver. But we will not go into that. I'll stay with this framework, 5 plants, 5 markets, and just familiarize yourselves, okay, on how the results are interpreted. Okay, and I think I've given you already what they're supposed to mean. Okay. Okay. Now, the previous model that I have discussed can further be refined by including in your decision variables the possibility of letting the flow of goods pass through warehouses. Okay. In our previous model, we just assume that production from certain plant are distributed to warehouse and market are aggregated there. Okay, that's aggregated as a single outlet. Okay, but if you decide to include warehouses and the suppliers also, okay, you can provide a 4-stage model, more complicated, of course, and more difficult to solve. But we will not go into that here. No? Just understand that previously, okay, the capacity facility model that I've shown you involves only the producer, that is supplier and plants, and the warehouse and market lump as one category. And you are going to allocate now how many plants to operate and how to distribute their output. That was the intention there. Okay. So again, if you should you decide to go further than what I have explained earlier, then these are the model that you have, the parameters that you have to consider. And of course, uh, uh, more, I would say, variables in your objective function. And you have to minimize. Uh, you will have to add other cost factors that involve warehouses and the suppliers. Okay, more complicated and more difficult to solve. But again, as what I said, this is for your information. We will not go into that. Okay. Yeah. Yeah. These are other technicalities involved. Okay. I will skip that. Now, another refinement, of course, is when you want to account for taxes, tariffs, and other customer requirements. Now, when these things will confront you, okay, remember that what we have discussed in the earlier model, the capacity positive planning capacity facilities location model, uh, it was a simpler one. Okay? It doesn't involve, it only involved the variable cost of producing and shipping plus the fixed cost of operating a particular production facility. But if you want to, that's why the objective there is minimizing cost only. On the other hand, if you want to consider for this, especially if uh, uh, different location has different tariffs and taxes involved, and that's particular too when you operate outside of the ASEAN. In the ASEAN, normally it's standardized, okay, because all members have preferable, preferential arrangement. But if you go beyond, then you may have to use this one. And this will require you to change your objective function. Instead of minimizing cost, you just have to maximize your profit. Okay? And maximization of profit actually will require additional information. In fact, the first factor in this objective function is actually the revenue times the number of quantities that you're able to uh, produce and shift, minus the fixed cost of operating the plants, minus okay the uh, uh, all the costs that will be involved. No? This includes uh, variable cost and of course the cost attributed to taxes, tariffs, and other customer requirement. Okay? It's all there. Okay? So become more complicated and become more difficult to solve. But it can be handled still by the solver method, no? Provided the number of variable and number of constants are not too much. Okay? But this is only for your information. We will not go into that in this course. Okay? Making network design decisions in practice. No? Well, you are equipped with tools such as the capacitated facility location model and probably other models that you could use. No? But I would like to enumerate, no, before I close this discussion, some important practical issues that you have to really consider. Number one, uh, do not underestimate the lifespan of facilities. No, well, normally when you create a facilities, you basic assumption is that it will last for at least 5 years, and normal for buildings and other plants must 50%, 50 years. But pay close attention to that because facility uh, are very expensive investment. So you just have to do some more closer look at the lifespan. So probably conduct more studies just to make sure that you are in the ballpark. Do not gloss over the cultural implication. Normally, when you do supply chain network analysis, it involves a lot of countries, and we all know that different countries have different cultures. Okay? Do not ignore quality of life issues, especially now in the era of pandemics, the era of sustainability. People now are starting to realize the value of quality of life. And lastly, focus on tariffs and tax incentives when locating, especially global or regional facilities. Now, when you go outside of the countries, then tariffs, taxes already are different from your own country. So you better consider that in your decision making. Okay. Okay. So that ends our lesson for today. Well, as usual, if you have questions or need further clarification, you'll have several options. Firstly, you can post it in our discussion forum, of course, corresponding to the module where it belongs. Secondly, feel free to email me following our established email protocol. And thirdly, feel free to raise them up during our forthcoming interactive virtual conference. My only request is be specific and provide me details of the reference document page and or slide number, preferably ahead of time. Thank you for watching. Keep safe, stay healthy, and good day once again.